Similarly, an analysis that may encounter similar problems is area calculation. How do we calculate the area of a polygon? It's actually, again, relatively straightforward. This is, again, not something that you will actually have to do whilst working in the GIS. The computer is going to do this for you, but we can see it's quite a straightforward. There are two versions of this. Here we can say that the area of this polygon here that is described, we're going from that point to that point to that point to that point to that point and back again, defining this area, is half of the sum. This is the sum of stepping through whatever these are, going from the from this 1, that I there references these this 1 down there, then this 2, then this 3, then this 4, then this 5, going up to whatever the maximum value of it is, which was 5. And then we sum this calculation. So for every step, we have the y coordinate at 1, and then multiply that by the x coordinate of the next one up, so I plus 1. So if we're starting at 1, it's 2, minus the x coordinate of the previous one. Well, we need some logic here to help us work out that must be that one there, the 5. But we can do that step by step for each one, and then we sum those up, halve it, and we get the area. So if we just take, as an example, we'll start at 3 here, up here. So this is where I is 3, and the x coordinate is there. And then we're going down to 1 here because we're working on this 2 line here because we want the plus 1 and the minus 1. So that was our I plus 1, and that's I minus 1. And then we put those in there. We take the y for the current point, which is that one there, and that gives us the 5 times minus 4 is minus 20. So for that row of our calculation, we've gone I minus 1, I plus 1, and then the I here. So that's with there, that's the 2 there, that's the plus 1 there, and that's the minus 1 there for that calculation. We do that over and over again, step by step for all of them, sum all of that up, halve it, and we get our area. Similarly, this time only using 2 points. If we go back to the previous example, we had to keep in memory, or the computer had to keep in memory, both this point, and this point. In this formulation, we see that we have I and I plus 1. We don't have I minus 1. So this is a slightly different formulation, and we need to calculate the absolute value of the sum afterwards to get, because we can see here we have a negative 49. There's no such thing as a negative area, even if ArcGIS Pro can on occasion calculate negative areas, which it then doesn't like afterwards. But there is no such thing as a negative area. So we need to calculate the absolute value of it. But this works in a similar way. We're summing up a calculation. We take these, this is our xi, and this is the yi plus 1 minus the next step, which is x plus 1, xi plus 1 times yi for the Geordies. And then, so we multiply those together, subtract one from the other, sum them all up, and then we get our answer. As I said, as a side note, ArcGIS Pro can actually calculate negative areas when doing buffers. Rarely, it does happen. I've seen it happen, and it can create some annoying problems. It should warn you. It doesn't. Why? I don't know. But be careful of that. So if you have something, if you have some process, some calculation that isn't working when you've been using a buffer, check to make sure that it hasn't calculated negative areas somewhere, because that may be the problem.